very good morning and welcome to the group assignment of digital marketing and analysis. So, in this project, we will examine the customer data, which is the file name is customer underscore data.csv, which is a data set, and we will also document the journey of data pre-processing and finding the missing values, removing outliners, and other data quality issues. Furthermore, we will also do an EDA exploratory data analysis to identify trends and relations in which will lead us to model selection and estimating CLV. Once the model is selected, we will train and test data and use cross-validation techniques. And finally, by highlighting the most important feature to predict the customer lifetime value. Starting with importing the libraries and loading the data. In this Python script, we will start by importing several essential data libraries for data analysis and visualization. These libraries include Panda SPD, then the NP as NumPy, Matplot library, Seaborn, Simple Imputer, and starts from Skippy, and etc. After importing these libraries, we'll proceed to load the dataset from Excel file using pd.read underscore Excel. The dataset is stored in variable df. It appears that the dataset contains information about customer, including attributes like customer ID, gender, marital status, annual income, age, promotion type, city, etc. Now, after moving on to the next stage, which is data analysis and pre-processing, in the provided code snippet, we observe that a series of data analysis and pre-processing steps performed on a data set. So let's break them down and provide context to each step. First is data transformation. The snippet begins with a list of numeric columns in the data set being extracted using df.select underscore df types and stored in numeric underscore calls. This step is crucial and important for identifying the columns containing numerical data that may require further analysis. In the similar way, we have outliner detection and handling, which for each numeric column, the code calculates the quartiles and the interquartile range. And the similar way, any points falling outside these bounds are considered outliners and are filtered out from the data frame. Categorical column handling, we also implement categorical column handling. Outliner replacement. In outliner is replacement for each categorical column, the code calculates the frequency of each category and identify the outliner for those with a frequency less than 1% of the total. So these outliners are then replaced with NaN values for later for imputation and analysis. And furthermore, after that step, we move to data visualization. After data pre-processing, the code imports the Seaborn and Matplot libraries for data visualization as it selects a subset of categorical columns. Now, talking about data visualization, in this section, the previously prepared categorical columns are visualized using count plots for each category. Here's the context for each part of the code. Flattening axis, then we have count plot iteration, then we had plot tiles axis, label rotation, we have adjusting layouts, displaying the plots, print column names, and numerical columns. Each one of them playing a crucial and important role in data visualization. I'll not elaborate on each one of them, but I will elaborate on two of them just to give you an idea what some of these things do. For example, adjusting the layout of the subplots is adjusting using the plt dot type, which is the file's name underscore layout, to ensure that they do not overlap and are neatly organized. Another function is numerical columns, which is a list of numerical columns is defined as numerical underscore columns, which includes attributes like age, annual income, different amounts of pay, amounts paid, etc. These columns are likely for candidates for further numerical analysis or modeling. So as you see, the codes of the snippet effectively creates and displays the count plots to visualize the distribution of categorical data within the data set, providing insights into the composition of each category. Now moving further to the box plots for each amount paid by promotion. Now, in this basically, in this section of the code, the box plots are basically generated to visualize the distribution of amounts paid on different promotions of specific quarters. And to add context to the code, there are columns to the plot, then there are creating subplots, there are iteration over columns, there are plot tiles, and y-axis label. So basically, the code effectively creates a set of box plots, one for each column specified in column underscore two underscore plot two, which is the name of the file again, to visually compare the distribution of amounts paid across different promotion specific quarters. The plots can help identify the variations and potential patterns in payment behaviors associated with different promotional activities. Moving on to the regional analysis, which is also a part of data visualization. In this section of the code, basically various data visualizations are created to analyze and compare data across different regions in the data set. To add context to each part of the code, again, by adjusting layout and displaying previous plots, phase grid histograms by region. This is basically the code uses the function which is sns dot phase grid phase t grid function to create a grid of histograms, one for each region in the data set. This is basically a parameter that specifies the grid should be based on the region column. Again, moving on to stacked bar chart for payment methods by region. This actually basically is a stacked bar chart to visualize distribution payment method using different regions. Now, next is average amount paid by quarters. This is basically a line plot is created to visualize the amount paid over different quarters, providing insights and trends into patterns, customer and spending behavior. Each one of these functions give us deep, meaningful insights and about sound behavior of a customer and their actions and their spending power. Next is model creation and feature selection. Talking about model creation, feature selection, there are few things that comes under it, which one of a few of the things are building model, data splitting, model training prediction, model evaluation, feature important analysis. Basically, model evaluation is basically evaluating the model's performance using the matrix like mean absolute error, mean squared error, and r pi square. In the similar manner, building model is basically importing the necessary library to the random forest regressor, creating the random forest regressor model within specific parameters, defining the features which is to be used in the model, and importing library. Data splitting is basically splitting the data into training and test sets. 70% is training, 30% data set, and we have used the 70-30 to split train and test data with 100 tree and random state 42. Moving on to the features most important analysis, feature importance analysis, which is extract feature importance from the model, display and sort features based on their importance. Feature and importance are evaluated, sorted by descending order, and found that amount is paid by the most important attribute.
So
Next. Okay.
moving after Ankit, so he has already defined how the EDA steps are done and the visualizations that are done across the Python to help get insights about the customer behavior and which customer comes from which profile and how much revenue we are collecting from him over quarterly of a year. So further on, I would talk about the how the model is created. So the traditional way to split the data is 70-30 or 80-20. So in this, we are using 70-30 rule to split the training and test data sets. Then what we are going to do is like we are predicting a customer lifetime value cycle. So it's something a numerical value. So we are going to use regression problems. So I also use linear regression, but the results were not pretty accurate. So I moved on to the random forest regression, trained on selected features, and predictions are made on the test data. And other than this, after making the model, we also taken care of the metrics. Like we have involved basically three metrics: mean absolute error, mean square error, and R square to know the accuracy and precision of the model in predicting the CLV. So then we also made a correlation analysis and visualization. In this, we have done a correlation analysis of all the features with the target variable CLV. And also a correlation matrix is shown inside the code, and it says that the amount paid is the most important feature for predicting CLV. Visualizations has been done after that. Scatter plots are used to check linearity and residuals. Residuals are basically y tested minus y predicted. So a histogram is made for residuals that shows it is normally distributed around the mean, and the QQ plot is also made for residuals. So after that, we also made some KPIs that should be considered while making the model. So the main KPIs are we have to find the CLV, the customer lifetime value cycle, the mean absolute error, mean square error, R square, and the important feature that will help in predicting the CLV. Moving on. So first, we selected all the features that are included in our dataset. Then when we checked, we found that some of the attributes are not helping to predict the CLV. So in this correlation analysis, we found that the product type of service user, these are not helping to predict the CLV. So we remove the features with zero importance. Again, split the data. So what the tree size is 100. So N is 100 and the random state is 42 with a 70-30 split.
Mm-hmm.
So then correlation analysis is done. Analyze the correlation of all feature with target variable CLV. Performed a correlation matrix on the CLV to understand its relationship with the trained data set. Values near to 1 are considered highly significant. That means that they are most significant in predicting the CLV, what we are predicting over a
Mm-hmm.
time. Then visualizations are also done. So after that, the what main KPIs were found are CLV. So basically, CLV is the total sum of revenue collected from a customer into the frequency of purchase. So we don't have a frequency of purchase. The data is only for 1 year, and ACL is then 1 year. So CLV is basically the sum of all quarterly payments. We calculated the CLV. Then what we found in model, so the three metrics were mean absolute error, mean square error, and R square. R square is most important. So R square is around 0.99. That's pretty well. That means the model is working perfectly well. We can also
Mm-hmm.
see in the graphs in the visualization that we have made in assignment that the actual and the predictive variable are very close, and they have residuals are very less. So residuals are low. That basically means that the predicted values align very close to the actual values. And feature importance is already Ankit told that amount pays is most important feature. So it has a value in correlation matrix of around 0.99. That means that amount paid should be included in predicting the model. So that's all I wanted to tell. Now, Ankit will.
Okay. Thank you so much for watching this video. I hope we were able to share some useful and meaningful insights using the functions, the regressions, and we were able to apply these different methodologies using data visualization, transformation, and pre-processing, and also using these scatter plots and regression techniques to analyze the customer behavior. So this is it for today, and thank you for watching.